So here today we're going to be reviewing the two factoring methods that we've learned so far in this new unit. So hopefully you've done the work prior to this because I've taught you all of this. This is just me kind of reviewing, factoring out the GCF and factoring by grouping. So have a pencil and be ready to take some notes as I go through some of this, and then there'll be a practice that I'll explain that I want you to try to wrap up this, but then you won't have some e-learning for a while since you'll be on spring break. And so after spring break, we'll come back and learn some other ways to be factoring. So today I'm going to do a quick factoring review over the greatest common factor, or GCF, and grouping. And then I'm going to just specifically look at some questions here and say, which method do we use? Is it GCF? Is it grouping? And then I'll show you some more examples of how to factor with using those two methods. And then again, I will explain the practice that I would like you to complete. So hopefully you are already able to determine which factoring method to use in order to factor a given polynomial, but today we're specifically just looking at that GCF and grouping. Hopefully you already know how to do that, and that this is just a quick refresher. If not, I encourage you to go back to last week's work that was posted in Canvas under the title E-Learning Week of March 23rd. There were some videos that I did, links there in that document to show you how to factor with GCF and factor with grouping. And we're just going to be reviewing that today. So to review greatest common factor here, remember you are finding what each term has in common. Okay, so you'll then want to factor that out, and remember when we factor out, we are dividing each term by that common factor. And so then we have to write our final answer. So when I take a look here at this problem, okay, I see I have a 45, a 36, and a 45. Okay, so I like to go to my smallest number, so that would be 36, and think of its factors. So like 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay, so if I think about those numbers there and 45, I know that 2 doesn't go into 45, so that's out. 3 does go into 45. Let's see, 4 does not go into 45, 6 does not go into 45, 9 goes into 45, 12 does not go into 45, and 18 does not go in, and 36 doesn't go in. So I have 1, 3, or 9, and 9 is that greatest factor that they have in common. So I'm going to factor out a 9. Okay, now I want to look at the V's. This one has 9 V's, this one has 4 V's, this one has 3 V's. So again, I could write them all out. How many do they have in common? They have 3 in common. Remember, we want to go with that lowest exponent. Okay, so that is my greatest common factor there. I'm going to factor that out, and I have to put what's left once I factor that out. So I'm going to divide each term by 9v cubed. 9v cubed. 9v cubed. So 45, so let's take a look at this first one. 45 divided by 9 is 5, and there were 9 v's, and I'm taking 3 out, so there are 6 left. Okay, my next one, I'm going to look at negative 36 divided by 9, which is negative 4. There were 4 v's, I'm taking 3 out, so there's 1 left. And then my last one here, 45 divided by 9 is 5, and there were 3 v's, and I'm taking 3 out, so there are none left. So this is my final answer using that GCF method. So remember, your greatest common factor is out here in front, and then you're dividing by that to get what is left. And if I were to distribute this back out, I would get the original problem. Quick review on grouping here. Remember that there must be 4 terms in order to do the grouping method, because we have to split the problem in half, and then we have to use the GCF method on each half of the problem separately, and then factor out that GCF to get the final, to get what's left. Remember, their parentheses should be the same when you use this method, and that's why we can do that other final GCF problem at the end. So just a warning here, though, that just because it is 4 terms does not mean that it's grouping. So I'm always wanting to look for GCF, but when I look at this problem here, they don't all have x's, so I know they don't have those in common. 35, 14, 30, and 12. I was thinking 2, but 35 is not even, so 2 doesn't go in there. They don't have anything besides 1 that's in common. So I know that I have to use grouping with this because it is 4 terms and there's no GCF. Okay, so I'm going to split my problem in half. So I have 35x cubed plus 14x squared as the first problem. Those are the first 2 terms. And then my last problem is the negative 30x minus 12. Okay, so I'm going to do these separately using that greatest common factor method that I just looked at. Okay, and when I look at 35 and 14, the number that they have in common, the greatest, is 7. And then they have 2 x's in common. Okay, so I'm going to divide out 7x squared on each of those terms. So 35 divided by 7 is 5. There were 3 x's. I'm taking 2 out, so there's 1 left. And then 14 divided by 7 is positive 2, and there were 2 x's, and I took both of them out, so there's nothing left there. So there's my first half. Now my second half of the problem, remember, I should get that 5x plus 2 in parentheses. Okay, so when I look at negative 30x minus 12, the number that they have in common there is 6. I'm going to take out a negative 6, so I'm going to divide by negative 6 on both of these. Negative 30 divided by negative 6 is positive 5, and the x is still there, because I didn't mess with that. And then negative 12 divided by negative 6 is positive 2. So now I see that those parentheses do match, so I know that I'm doing this problem correct. Okay, well now that they match this whole problem, they still have a GCF, and it's that 5x plus 2. So I'm going to factor that out. Okay, so if I factor that out, let's see, I'm going to, so if I divide by 5x plus 2 on both of them, those cancel, and I'm left with 7x squared minus 6. So I factored out that 5x plus 2, so that's part of my answer. And then the other part is once I factor that out and divide, I get that 7x squared minus 6 left. So there is my final answer for that grouping problem. All right, so remember that later on, once we learn a few more methods, everything's going to be mixed together and you're going to have to decide which method to use. So before we move on to another method of factoring, we're going to slow down a little bit here and just practice looking at the problems, looking at the polynomials, and figuring out which method do I use. So for right now, you're just deciding between greatest common factor and grouping. So when I look at this problem here, I notice that all of them are even numbers. They don't all have b's, but they all are even numbers. So I know that I can factor out a 2. So which method would I use? That would be greatest common factor. Okay, let's take a look at this next one. 4 terms, so it might be grouping, but again, I want to look, does it have something in common, all of the terms? So they do not all have an n, so I know that they don't have that in common. 6, 10, 3, and 5. Well, 3 only has factors of 1 and 3 doesn't go into 5, 3 doesn't go into 10. So they do not have anything in common, and there are 4 terms, so I would use grouping for this problem. Okay, let's take a look at this one. Again, there are 4 terms, but I do need to double check to make sure there's not a greatest common factor. So they do not all share the same variables. And the lowest number here is 5, so it only has factors of 1 in itself. 5 doesn't go into 6, 5 doesn't go into 12. It does go into 10, but remember, it has to go into all of it. So I cannot use GCF. This problem is a grouping problem. Okay, take a look at this one. Which method do I use? Okay, well, there are 4 terms again, so maybe it's grouping, but I do need to check for a GCF. So they do not all have the variable. But when I look at the numbers 20, 18, 2, and 4, they are all even, so I know that I could factor out a 2, so this one is greatest common factor. I would use the greatest common factor method for that problem. All right, what I would like you to do here is pause the video and go through and try to decide if you're going to use GCF or grouping for each problem. And once you've spent some time thinking about that and jotting that down, go ahead and resume the video to get the answers. Okay, so hopefully you jotted down what you thought each problem was, either GCF or grouping. But I'm going to go through here. I'm not going to solve them. We're just determining which method is needed to factor the polynomials. So number 1 here, I noticed they do all have variables in common, and then 40, 50, and 40, they would have 10 in common. So that one I would use GCF. Okay, number 2, they don't all have m's in common, and they do not have a number that all of them goes into all of them except for 1, because the second term only has a 1 there. So here I would use grouping since there are 4 terms and there is no GCF. Okay, number 3, they share variables, and 7 would be a common factor that I could factor out, so that one is GCF. Okay, number 4, well, let's see, they don't all have x's, they don't all have m's or n's. 21, 15, 49, 35. 15 has 1 and 15, and 3 and 5. Let's see, 3 goes into 21, but it doesn't go into 35 or 49. So this one would have to be grouping since there is no GCF there. Okay, number 5. There are 4 terms, but they all have n's, so I would use GCF for this problem. And number 6, they don't all share a variable. Let's see, the n only has a number of 1 there, so they don't have any numbers in common either. So that one, because there are 4 terms and no GCF, would be grouping. All right, so now what am I going to do is talk through which method I would use, and then also go ahead and show how to factor that with a few examples here. Okay, so on this problem here, I would notice that there are 4 terms. They don't all have a variable in common. The front term has a 1 here, so they don't share a number either. So that means I am going to go ahead and use grouping here. Okay, so remember we split that in half, and then we have one problem here and one problem here. So with my front problem here, 1 and 5 are the numbers, so the greatest common factor is 1, so that doesn't really matter. And then they have 2 x's in common, so I'm going to divide by x squared on each term, so I get x minus 5 as what is left. Okay, over here on negative 6x plus 30, I'm going to put negative, and they have 6 in common, so I'm going to divide by negative 6. Okay, and I get positive 1x and then minus 5, and they do match, so I know that I did that correctly. So because they match, they have that, these 2 terms have a GCF, so they have x minus 5 in common, so I'm going to factor that out. That divided by itself cancels, that divided by itself cancels, and I have x squared minus 6 left. So x squared minus 6. So that is my final answer here. X minus 5 times x squared minus 6. Moving on to the second example here. When I take a look at this, they do not both have a variable. Okay, so I know they don't have that in common. I'm trying to decide here if I would use that GCF. It's not grouping because there are not 4 terms, but do they have something in common? I don't know. Sometimes some of them might not be factorable. So if I look at 56 and 64, I know that 8 goes into 56 and 64, so I'm going to go ahead and take that 8 out. They both don't have a variable, so I'm just dividing by 8 here. So I would get negative 7m to the third minus 8. Okay, now if you wanted to, you could have taken that negative 8 out. You could have taken the negative with it since they both have it. So if you divide by negative 8 instead, then you get 7m cubed plus 8, which if you distribute these, you get the same answer. So it doesn't matter which one you do there. But that one was using the GCF method. All right, this next one. Okay, well, I see that they have a 4 in common. They don't have variables in common, but there are not 4 terms for this, so we know that we have to use GCF here. Okay, so they do have a 4 in common, so I'm going to divide by 4 on each term, and I get negative 3 plus x left. 1x or just x, it doesn't matter what you write. Okay, another example here, there are 4 terms. but I want to make sure there's not a GCF. So let's see, 6 and 15, they have 3 in common. 3 doesn't go into 8 and 20, so there's not, let's see, 2 goes into 6, 8, and 20, but 2 doesn't go into 15. So there is not a GCF. So I'm going to go ahead and use grouping here. So split that in half so that I have my first problem and my second problem. On the front here, they have 3n squared in common. So I'm going to divide by 3n squared. And I get 2n minus 5. Okay, over here, they have they have 4 in common, so I'm going to divide by negative 4. So I get 2n minus 5. And my parentheses do match, so I'm going to divide by that. They have that in common. So I'm factoring out that 2n minus 5. Those cancel, and what's left is that 3n squared minus 4. So 3n squared minus 4. So there is my final answer. All right, so I would like you to go to Canvas and go to the quiz that is labeled Period 2, e-learning week of March 30th. This is your only required practice for this week since we only have a couple of days this week before spring break. There is also an optional practice that is attached on Canvas with the answers so that if you want to do extra practice just to make sure that you have these methods down before we go to another method after spring break, you can do that. If you are having any trouble at all, like finding the Canvas quiz or submitting the Canvas quiz, please email me. Please make sure you're staying safe and healthy. Feel free to check in with your other classmates. There's several classmates that haven't done any of the work. So, you know, if you have certain people that you always talked with at school or you text with or emailed them all the time, you know, make sure to try to make contact with them and make sure that they're doing okay. All right, have a great spring break, and I will be back April 13th with some more factoring work.